Welcome to the first lecture for visual design here at the Master of Human Interface Technology. And I'm Christoph Bartnek, and I'll be taking care of the track for design. And the course or the track I'm going to offer has the goal to teach you typography and essentially the craftsmanship of design. It means I will not really go into artistic design, meaning talking about different artists and what their style was or things like that. So I will not be giving you any guidance on that. But I will give you essentially an introduction to what are the basic rules, how are things done. And these are sort of like the rule of thumbs, as many rules there may be in visual design, I'm not even sure. But the point is, before you can break the rules, you need to know what the rules are. So in this case, we will be talking about typographical rules. So after the course is done, you can then go off and do all kind of crazy things. But for now, we want to learn how things are done properly. May be boring, but nevertheless, again, before you can effectively break the rules, you need to know what the rules are. The course content is actually laid out in a way that we start with the very, very smallest parts of visual design, and then over time we will actually increase the size. It might be a bit blurry right now what I actually mean with that, but it will become clear to you over time. The other thing is that I'm also going to do a second gradient, which has to do with automatic design. So we start out with doing everything completely manually, and in the end, everything will be done automatically. So there'll be a second gradient along that as well. And again, this is not probably very clear to you at this point in time what I mean with that, but it will become clearer over time. So it means today we're going to do the smallest possible things, and we're going to do it all ourselves. The meetings that we're going to have are structured in a way that we would first review the tasks that you completed in the previous week. But of course, since this is the first week, there's no task to preview or to review. Then we'll have a conversation, so that's what we're going to start with today, about design and the topic at hand. And then I'll introduce you to new tasks that you are expected to complete for the next week. Now, the tasks I ask you essentially are very often files that you have to create. And I would like you to use a certain file naming structure that helps me to identify who did what. So if you would please name your files last name _ task number dot, whatever it might be, PDF, PSD, or I don't know what. Also, please use Learn to submit all of your work. There are set deadlines. So that means that the Learn system will stop accepting uploads at the time and the date of the deadline. There is no late submission. As a rule of thumb, don't submit on the day where this is due, because things always go wrong. Printers stop working, toner is out, computer crashed, software update is available. All kind of things happen that will actually, disable you to submit your work. So plan in a certain safety buffer that you are able, if anything goes wrong, that you can actually recover from it. So for example, if your laptop gets stolen, or if the license that you're planning to use expired and you cannot talk to them because it's a weekend and they don't respond to your email. There's all kind of things that will happen, and I can guarantee you they do happen. So in that sense, plan in a safety buffer so that you're ready not on the day that the work is due, but actually the day before, at least. The resources that I mention here, I all linked them up on Learn. So that might be sometimes documents. It might be links to books, might be videos, might be all kind of things. So I usually set links inside of Learn. I'm also uploading the presentation, the slides that you see here right now, also to Learn after the lecture. That means you don't actually have to, copy everything. You don't have to copy things that are on there. You will actually be able to look at them afterwards, at just the PDF file. So, but if it helps you, to pay attention and to grasp things, that if you want to sort of like, write along or scribble along, that's perfectly fine as well. Okay? You will all have, or do already have, computers. And you will also need certain pieces of software. One of the essential pieces is actually the products from Adobe. We do have licenses for those. I am not essentially sure if they are already installed on your computer, but if not, then Lee will be able to assist you with it. Okay? Any questions about practical issues?
If we primarily use our own laptop for work, can we get the Adobe Suite installed on there using the existing licenses?
This is something we do not really like to see. Predominantly, we are responsible for the licenses. So if you would install on your laptop, and if you should decide to keep it afterwards, then that would not be very good. So we have, computers are being made available to you here, and we can guarantee you that the software will work on those. Anything else, for example, if you want to acquire a student license for the Adobe products, that's perfectly fine. If you want to install that on a computer, it's also perfectly fine. They currently run around 350, 400 New Zealand dollars for the complete Adobe design package, for example. So they're reasonably priced. They're rectangular in a vector format if you wanted to, right? So that's possible. But still, so the underlying issue is that a lot of data that we have actually from the real world, for example, digital cameras or scanners, it's just not vector, and photographs are not vector. That's not how they come in.
And so the color representations, how are you meant to do that in vectors? It's not easy.
So when we talk about bitmap graphics, what's the advantage of that?
It's simple for in terms of computation.
The file format's going to be exactly the same each time. It's easy to read.
What are the disadvantages of it?
Just the amount of data, the size of the data.
Yes.
It's directly proportional to the quality of the graphic.
Yeah. So who of you has ever tried to print a poster?
Yeah.
Yeah? And let's say you would have stored it as a PSD file, and all of your things are in there. Let's say an A0 poster in PSD. Did you ever try that?
Yeah.
What's PSD?
PSD is the file format for Photoshop.
So that's a vector one?
Well, these days everything's mixed, but predominantly it's bitmapped. So it could also be TIFF or JPEG. Or JPEG is a bit cheating because of the compression. But anyway, so have you ever tried to print a poster?
Yeah. And I'm doing T-shirts at the moment, experiencing all of these issues.
I use vector graphics when I make posters for precise reasons. I can scale it to the page that I want.
Exactly. Yeah. So, and let's say if you wanted to convert a vector, as you said, in the end of the day, if you present it on the screen, you have to convert it to pixels anyway, right? So how do you do that?
So you need to have something which can read the rule that the vector graphic describes and then converts from that rule to a bitmap. So I guess some function which does the mapping between the two.
Exactly. Well, that's what I said, a function. But how does that work?
How does it work?
Uh-huh.
Well, it would depend on the system. You need to take into account the size at which you're displaying the system on, so that would have, so there'd be some variables in that function which are, how do you guess. Yeah. So they're like they're values of the system that you're using. And it's like the screen size you're on.
Yeah. What's the name of that anyway? How do you call this process?
Vector to bitmap conversion.
Yeah. Yeah.
Never really thought about it. I just use it.
Mm-hmm.
I gotta sort of understand what's going on behind the scenes. But
It's called rasterizing. That's the one. Yeah. So what do you do?
So many times.
So what you have is you have a circle, right? And then what you do, you apply a grid to it. And this grid essentially is what?
Screen.
What does the grid that you put over the circle determine?
Sampling rate.
I'm not sure what you mean with that, but
Like the pixel, the bitmap, sample locations.
that's a lot of words. So let's take an example. Let's say you have only like, let's say 10, the grid has 10 boxes versus it has 100 boxes. What will change with the resulting bitmap? The resolution. So the finer the grid, the higher the resolution. Okay. And if you do it the other way around, well, now it's already on the screen. It's called tracing. This is complicated, as you already pointed out, but programs such as Illustrator, it's built-in functionality. So you can actually convert a bitmap into a vector. It will not look exactly like the bitmap unless, again, you would ultimately define every pixel as a rectangle as in vector. So in that sense, it's some sort of abstraction, and some people like this effect and actually use it because it has a certain style to it. But still, sometimes it can be quite useful. Now, there's a couple of terms that came up by now, and you have to help me understand them because I pretend I don't know them. So, the word came up, pixel. What is a pixel?
Light source.
A light source. Like the sun? Uh-huh.
You can have e-ink displays though, which are passive, so that they just,
Okay, in that sense, they're not a source of.
so they just reflect light rather than emit light. That's still a source. It's a sync source combination.
No, so seriously, what is a pixel? So one thing you refer to is it's something on that can represent light or reflect light.
It has coordinates.
It has coordinates. Okay.
Color representation of a particular, not any object in particular, but the end result of what's to be displayed.
Mm-hmm.
But we're not talking about a series of pixels. That's the end result. We're just talking about a definition of a pixel.
It's a color representation of data.
I think it's relevant to talk about the screen as a whole and the fact that a pixel is a member of that screen. Even if it was a single pixel screen, it's still.
So what you're referring to actually is an ambiguity in the term pixel, because it actually has more than one meaning. So what you previously described is actually a physical property of a display. Right? It may be an e-ink display, or it may be a computer display, or it may be something else. Right? So it is something that will create a certain color impression essentially on this very same computer screen, but also up there. Right? But then we also use the term for something else. And for what else do we use the term? And you already mentioned it as well, in a way. So what is a pixel? Very good, very good. It is a piece of information. Okay, now let's get nasty. What is the size of a pixel?
1 unit.
Yes. And what unit is that?
It can change depending on what you're displaying.
Aha. So then if I ask you the size of, what is the size of a pixel? The answer would be?
Any size you want.
Yeah, or, well, it depends. Okay, so the answer is the pixel has no size. It depends on the display on which you present it. Right? So that leads us to the next question. Well, for this screen, what is the size of a pixel?
Width divided by the width of the screen divided by the number of pixels along the width.
Mm-hmm. And how would you call that concept?
How would I call it?
The relationship between the number of pixels and the length or the dimensions of the display. Velocity.
That's right.
Screen resolution.
Absolutely. That is resolution. So, now here's an interesting question. If I ask you, what is the resolution of your, do you have a laptop?
Mm-hmm.
What's the resolution of your laptop?
Gosh, it'd be like 1333 by 768.
So is that a
It's
resolution?
a 15.6 inch diagonal screen. So from that you should be able to extrapolate the size of each pixel.
Exactly. Now, the interesting thing to keep in mind here is that you started out with just naming the pixels. And that's a common misconception. When people ask you, what's the resolution of your screen, what they actually mean is how many pixels are there. They don't actually even think what resolution means. Mhm. Okay, so, and in what units is resolution measured?
Pixels.
Per?
Meter. It's weird. I don't know.
It's a relationship between the length and the height, length and width.
That is correct. And of course, you can make up any kind of combination, but there's one that is sort of used as a standard. Anybody knows what that might mean?
WXGA and VGA.
No, that is only the number of pixels again.
What was the question? Sorry.
What is the unit in which typically resolution is being measured or named?
If it was width to height ratio,
Mhm.
unit frame.
That would be a proportion, but it's not the case.
Oh, so I've lost what resolution means. Because I was traditionally using, I would say resolution is 1280 by 800.
Exactly.
And now I don't know what to.
So
what it's gonna call
that is exactly is wrong, because resolution is essentially a density function, right?
Right.
And it's not just naming the number of pixels. That is just how many pixels you have.
But wouldn't there be an upper limit on the resolution?
Well, that depends, no.
Yeah, that's, I don't understand the meaning of the word now.
So would you use like dots per inch DPI?
Exactly.
Okay.
No. Yeah.
So DPI is often named as the measurement for resolution. But here's an odd thing. What does DPI stand for?
Dots per inch.
Dots? What is a dot?
Pixel.
Is it?
Well, no, it's not. Because they do a funny transformation. Like, they increase the number of dots, but reduce the dynamic range of the dots, of the pixels, to simulate the same resolution using more dots with less variation.
Well, what you're talking about is possibly, well, if I understand correctly, something has to do with printing.
Yeah.
And of course, in printing, DPI is very often used. But
Right.
so the question now again, what does dot in DPI actually stand for? Bits?
Pixels.
Pixels.
I think so.
So yeah, this is the confusion. So we were talking about screen resolution. So if you have screen resolution, then DPI only makes sense if you know what a dot is. And if a dot is a pixel, then great, then it would fit. But if it isn't, then it doesn't. Okay, so we're going to make now a small detour and hopefully become clearer. Have any of you ever done web graphics?
A little bit.
Little bit? Okay. If you save a graphic, let's say JPEG, GIF, or whatever, what resolution do you choose it to be? I mean, keeping in mind, actually doesn't make sense to have a resolution for a screen graphic because the total number of pixels is actually what you're after. But still, you know, you always have to give a number there. You know, this cannot be nothing. So what do you usually use?
Maximum available.
No. There's a default value. What's the default value?
Something like 150.
Mhm. What's the default value? If you create a new GIF, what would it automatically put it into?
Too sure.
Well, if you don't know, you don't know. So then I have to just say it. It's 72. Does 72 ever came across you?
Oh, yeah.
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 I have no idea what context.
Okay. So why 72?
Is it a good number to divide by or something?
It's a very weird number, isn't it?
8 times 9.
Well, so the 72 question is something that we have to address. Now, point. Dot, I should say. No, well, let's make it even more interesting. Let's put something else in the big mix to confuse you even more. If you use Microsoft Word and you should say, I'm going to use a 12-point typeface, and if you print that, how tall will it be?
12 pixels.
On the print? 12 pixels, that would be interesting. Yeah.
But it has its own way of knowing based on something how many dots on the printer it comes with.
Mm-hmm. So first of all, what can we conclude when it says 12 point? Then point there, what does point actually, it's a unit, right? And it's a unit of? Size, yes, so length, right? So because the bigger the number, you know, the bigger the typeface will get, right? So if you have an M, you know, if it's 12, 13, 14, 14, the bigger it is, you know, the bigger the M gets, right? So do you know what then this point actually refers to? Okay, interesting, huh? You all use Word every day.
I'm pretty sure I've been told like way back in the day, but
Mm.
it's too real.
Okay. So, I hope I have now created enough confusion amongst all of you to sort of like come up with an answer that hopefully satisfies you. The points that you use in, for example, something like Microsoft Word is actually the same as no, that's wrong. So this unit actually is an historical unit, and this unit comes from the time of print. So printers have sort of like, they don't use centimeters, for example, to measure a height. They actually measure it in points. And 1 point is nothing else than 0.35 millimeters. Right? So it's just another unit. Okay. Now, who was the first company that came up with a really nice way of doing desktop publishing? No. I said a nice way of doing desktop publishing. Back in the 80s. Graphical user interface. That would have been the first one, but they actually didn't actually bring it out to commercial success. Who stole the ideas from Xerox? And Apple. So Apple did it. Now, Apple had a fundamental problem. If you do desktop publishing, what you want actually is that you want to match what's on the screen with what is on the paper, so that you don't actually have to print every time to see what it actually looks like, right? So the problem was the printers used points, and the computer screen uses pixels, right? So wouldn't it be really great if a pixel would have the same size as a point? Yes, and that's what they did. Now, 0.35 millimeter, you see it at the bottom down there, is actually, there are that comes from the printers, 72 points are in an inch. Right? So if your computer screen has as a resolution of 72 pixels per inch, then 1 pixel equals?
1 point.
Exactly. So then the concept of pixel and point are the same. So what you see on the screen will be roughly, actually size-wise, the same as you would see it in the print. And that's how 72 came along.
That's convenient.
Yes, it's very convenient, actually. And it only took a couple of years, and then Microsoft screwed it up. Because they came up with 96. For God knows what reasons. They decided, OK, no, we don't want that. We want to have 96. And then, of course, then you miss this very nice synchronization between the two, and then things get difficult. Because these days anymore, 72 doesn't even make any sense anymore, because the resolution of our displays has doubled since then, right? So the density of the pixels on an LCD screen are much higher than 72, which is in a way also nice, because the graphics can be much finer. But again, what you lose is the direct connection between pixel and point. So
You could use multiples of 72 to scale it.
you could do. But these days, these things have really become detached. And that's just the way it is. So if you really want to see how it prints, if you really want to see how it comes out in the printer, you have to print it. You cannot really easily predict it on the computer screen, right? So this also means that actually a dot in DPI is still a bit of a mystery. Because if you would actually say, the resolution of my screen is 96 dpi, then you make the assumption that a dot equals the pixels, right? But that's not actually the case. There's actually the relationship between how a pixel is printed is much more complex, right? So in that sense, it actually makes more sense to talk screen resolution in PPI, pixels per inch, for example, or pixels per centimeter, if you like. And that is how you measure the resolution of your screen. Or not, that's how you define or report the resolution of your screen, right? So if we have then a 10-point typeface, and let's say you have a letter G, with the bottom, and you have a letter H with the very top, how high will this be when you print it? No. 10 points. And a point is?
0.35.
So 10 points are?
3.5.
Millimeters. So if you choose a 10-point typeface, then your letter will be 3.5 millimeters tall.
So there's a zero line going along here. And up and down.
We'll come to that.
Right.
We'll come to that. How actually the size of a typeface is defined.
Mm-hmm.
We'll come to that. Okay. Now, so far so good. Have you ever had this problem that when you buy a new hard disk and it's supposed to be 1 gigabyte or 10 gigabytes or I don't know how many terabytes it is, and then you plug into your computer and then it's much smaller? Do you know why?
I did know why.
They define kilobytes in terms of thousands, and computers read them in terms of 8 bits, so you have 124.
Exactly.
But they should be using kibibytes and mebibytes. I think that's the new unit.
So essentially there's a bit of a problem in terms of definition, and companies like marketing, so they claim things to be bigger than they actually are.
Mm-hmm.
So if you have, let's say, an image that you want to display, so how many colors does this display have anyway?
Well, that'll be a 24-bit display, I'm assuming.
Are you talking about your laptop?
Mm-hmm.
What was the question, sorry?
How many colors does this laptop actually have?
24 or 32? I don't 32
So
bit.
maybe like 16.7 million or something.
Something like that.
Yeah.
Yeah. So, but how many different colors does it actually have? 3, which are? Exactly. So, if you want to store an image and it has 3 colors at different intensity levels, how many different intensity levels of red do we have?
0 to 255.
So 256. Right? So how many bytes do you need to store 256 values? 8 bits. And 8 bits equals?
1 byte.
1 byte. So for 1 pixel, how many bytes do you need? 3. Exactly. So this way you can calculate how much memory you will need to have an image in RAM. Right? You need 3 bytes per pixel. Excellent. Now, how many colors does the printer that we have, the laser printer over there? Well, you don't know it, but you don't know it either. So you have to answer the question.
Damn it.
How many colors does our printer have?
Like 3,000? I don't know. I haven't really delved into that. I haven't looked at the specs.
Mm-hmm. Do you have an inkjet printer at home?
No, it's a laser black and white.
So how many colors does it have?
All shades of grey.
Yeah, I hope so. I'm not sure if it's quantile.
That's true.
Yeah.
So what color is that?
Black.
Exactly.
Black.
I'm sorry, your printer only has 1 color. So if you have we also have an inkjet printer here, a color one. How many colors does that have?
3.
Which ones?
4.
Which ones?
Oh, if it's a printer, it would be, you've got a few options, but the red, cyan, and something else.
Yeah.
CNYK, cyan, yellow, magenta, and K's alpha value, I think.
So how many colors?
3 colors plus I don't know, 4.
That's correct. Cyan, magenta, yellow, K. K stands for key, which means black.
Yeah.
So usually, I mean, these days you get also inkjet printers will also have more different inks. It has changed over the last couple of years, but originally it's 4 colors, right? So, but let's say the easy example of your printer only, your poor printer only has one color. But how is it possible it can produce gray?
So I'm not entirely sure, but I assume that it's something to do with the length of time that it's producing ink. Like it's like a spray can, if you will. So if you just run a spray can over a board, it will be less intense than if you run it over a few times.
Mhm.
So I assume it's a similar system used there.
Okay. So here you've got a problem. Problem is, let's say you have a certain pixel. Let's say it's a grayscale image and it has a certain gray value. You cannot actually, if you only have one color, black, you cannot represent that gray pixel with the color black. You cannot make that just draw the pixel, because then you can only draw in black. It doesn't work, right? So what do you do? What other color do you have?
We have white.
Yes. So how then do you mix black and white to make gray?
Providing we don't actually have the color white.
Yes, we assume white is given through the paper.
So you're trying to create a type of transparency with the black ink, which is what he's saying. Like if it's not sprayed for the full time, it would make it black, and it wouldn't quite be black.
So, but I don't think at the time. What does the influence the time have here on how dark it is? Yes, but what happens if you keep this? I mean, the spray can also only has one color.
That's true, yeah.
Right? So what happens if you keep on pressing?
Well, it reaches the point where it stops getting
Fills
black.
in the space.
So the more space is filled with a color, the darker it gets.
Microsoft Paint and that old spray can.
Yeah. Okay, but this has a profound effect. If you want to have a pixel printed, you cannot have one piece of surface, because that could only take one color, right? So how much then do you need extra? So what does your resolution of your printer is? What is it actually?
I think it might be 72.
Resolution of your
DPI.
printer.
DPI.
Maybe 150 or 300.
Okay, sure.
I think it sort of
Yeah, I
depends
don't
on the technology.
Yeah.
You name something, a value which is commonly used, like 300. And we'll come to that in a second. But no, when you look at the marketing sheets, they will be much more. It will be like 1,200, 6,000, all these things.
Yeah.
So why do you need that?
Quality.
Yes,
Graphic.
of course. But remember, if I have my square, and if I want to have a gray value in the square, I cannot just have one surface,
I see what
because it will all be black. So I must have subdivisions. And if I subdivide it, and I then fill half of the boxes with black, and half of them I don't print anything, and the paper is white, then I have 50% gray, right? So that's why you need to have more resolution on the printer than you have sort of like pixels page, because you cannot represent a pixel directly.
So effectively, you're making like a checkerboard pattern inside a larger pixel,
Yes,
but broken down
Yes.
just to the point where the human eye can't perceive it as a
Exactly.
checkerboard.
So it perceives it as just one unit.
Exactly.
Yeah, that's really interesting.
Mm.
I want to get a magnifying glass.
Which in a way is also true for the screen. You don't have a pixel here of a certain color. You actually have three surfaces next to each other, a red one, a green one, and a blue one.
Yeah.
And that together gives, the mixture of it does represent one pixel. But here, the beautiful thing about an LCD display is that you can vary the intensity, right? This is something you cannot do in print. In print, you just have 4 colors, or you have 1 color, and that's it. That's all you ever have, right? So, which comes to an interesting question. If you print on a printer, what resolution is sort of like a good value?
6,000.
Why?
About the computer side.
If you have an image on your computer, and you have, let's say, we would have it in Photoshop, and it would be, have a certain pixels, but you also set the resolution for it, right? And that will determine how tall or how big, in terms of dimensions, in terms of centimeter, it will be when you print it, right? Again, resolution, DPI. So what is a typical value you choose for your photograph to be?
150 to 300.
Yes, that's a 300. So rule of thumb, 300. And this is something that very often goes wrong. You read your printer, 1,000 DPI. Wow, my image, I should have 1,200 DPI in my image. Not a good idea, because it's absolutely overkill. You will not be able to see the difference, right? The printer has to essentially subdivide pixels. So if you have your image and it's 300 DPI, you're good. More than good. So this is to make things more interesting even. What we talked about is sort of like inkjet printer and laser printers. Now, when you go into printing, this is not done with a laser. This is not done with an inkjet printer. No? This is not done with it. Oh, this is a black and white one. But for example, this one here, it's not done with an inkjet printer. What is this done with? No. Offset print. Right? Do you know what offset printing is? Okay. I'm not going to go into detail into what offset printing is, but roughly speaking, again, you've got 4 colors. And what you do is you have, again, no, I'm not going to go into it. In any case, these people traditionally use, again, a different unit again, called LPI, lines per inch, just to make things more interesting. It comes out of the question about how, well, no, I'm not going to get into that. So it is complicated, but as a rule of thumb, the idea is that for a book, if you want to have the best quality for a book, 300 dpi is all you ever need. You don't need more. Magazines are usually done with 266, so this is probably in the area of 266 here. If you buy a newspaper, it's usually like 170 dpi. So you don't need more than that. So don't yank up your DPIs and think you get a better quality. It's not going to happen. Right. Now, so much for that. Since we are in the funny game of dimensions and units, what's the size of this? Yes.
9.7 by 20 something.
21.
21.
Yes. Okay. So, why did they pick that proportion?
Golden rule.
Well, it's the same ratio when halved.
Exactly. So if I take this, so if I divide the length by the width, and if I fold it, and I get half of it, it is still the same proportion. That is not a given, right? If you have a rectangular, not a rectangle, but a square, it also has a certain proportion. And the proportion is 1 to? Okay. If I halve it, what is the proportion?
1 to a half.
Exactly. So the proportion changes. With this, it doesn't.
Depends which way you fold it.
No. If you half or double it.
Oh, sure.
If you do other crazy things, maybe. Okay. So this, what do you say, this A4? What does that mean?
It's the standard size.
Yes. What's the full name of it?
Never heard of
You just call it A? Okay. The full name of it is DEN, DEN, A4.
DEN.
And what does DEN stand for? Okay, a hint. What does ISO stand for? ISO.
International Standards.
Organization.
Yeah.
Okay. What does DEN stand for? Sorry, I have to be a little bit of a local patriot here. It's called Deutsche Industrienorm, German industrial norm.
I never want to come to that.
That's okay, that's a given. So essentially, it's just the Germans who cooked up this idea. In any case, this is about proportion, right? But this only defines the proportion. It doesn't actually set, for DNA 4 that it should be 21. It could be anything, right? So why 21 by 29.7?
Something off the DPI.
Mm-hmm.
Same size as a laptop screen.
Mm-hmm. There's some beauty behind it. So, DIN A0 has a certain length, right? And width. And you probably don't know exactly you can't recall by on your head what it is. But okay. Let's assume, again, these things usually go back to printing, right? So, if you are a printer, how do you buy paper?
Big pieces.
Oh,
Roll.
okay. Let's assume you buy in paper, and it comes like a pallet comes in. It comes shuffled in, right? And now the problem is, I want to know if all my paper arrived, right? Am I going to count every sheet? No, you don't want to do that, right? So what do? If you have a pallet full of paper, you want to know, is the shipment complete? What is the easiest way of doing it?
Measure the thickness of the whole thing.
Thickness, maybe.
Weigh it.
Very good idea, right? So, if you have this really big pallet, you shuffle it on, and you say you've got A0 papers, and it has a certain weight, right? How can I then easily conclude the number of sheets that's on it?
Thickness of the sheet.
Yes, you need to have the weight of each paper, right? Okay. And how is the weight of a paper given?
GSM? No. There is weight. It's thread count, isn't it, or something?
It's gram per, for example. So, if that is the weight, let's say it has 100 grams per, I think it's square meter? No, I think it's square meter.
Grams per meter. Yeah.
So, if let's say my paper would have, the density of 100, right? And I say, I get 1 kilogram, right? How can I calculate how many sheets of paper I have?
Divide the total weight by the density, and the remaining unit
Yeah,
should be.
but then you still need to know how much this single one that I mentioned it weighs. Huh?
So what does a A0 piece of paper weigh?
See, the beauty is that A0, if you multiply the width by the length, you get 1. A0 is equal to 1 square meter of paper. And that determines the absolute value, not the proportion, but the absolute value of that. And then you divide it down, right? So here it is, A0, A2, so A1, and so forth. But A0 equals 1 square meter. So if you have 1 kilogram and I have a density of 100 grams per 100 grams per square meter, how many sheets of paper do I have?
1,000.
Something like that. The point is, you can very easily calculate it, right? Again, when you create standards, you try to get to ease, right, to make it easy. So you know all A, the A series, you know, Dean A, 1, 2, 3, 4, 5, and so forth. There is a series called B, Dean B, 1, 2, 3, 4, 5. Have you ever seen that? And what does it say?
I'm not too sure. I got confused and stuck with A.
I bet all of you used it.
It's like postcards.
No?
American standards. Is it screen size?
Mm-mm. So if I want to send this, no, actually, yeah. If I want to send this by mail, what do I do?
Fold it up and stick it in the envelope.
Ah, envelope. So what does the B series stand for?
International mailing.
Envelopes.
Mm.
So that's what the B and the C series is about. A fits into B, B fits into C. Envelopes are the B series. Right? Now, the Americans, of course, they use something else called letter, legal, and tabloid. And they have the difficulty that they picked something which is almost as A4, but it isn't. In any case, they have the problem that the proportion doesn't stay the same. So, you know, legal is a double of, tabloid, tabloid is a double as letter, but the proportion changes. So it's not as elegant. And, you know, they only have 3. It doesn't scale. So it's really not good. The important thing that you have to keep in mind is if you create a design that is handled internationally, and if you want people to print that, you just have to be aware that letter is a little bit, has a different proportion. So make sure that you leave enough white space, but because it will be cut off, you know? So, some practical tips. Sizes. We already talked about this. This is the different types of sizes. And the aspect ratios, because this is what this was all about, is different in screens. So the typical ones, this old-fashioned was 4:3. Then we had 16:10 a lot. And these days, a lot of things are 16:9 because?
Widescreen.
Where is 16:9 proportion used these days a lot?
TVs.
In TVs, right? And because it was so incredibly popular with TV, and since the manufacturing of LCD displays and the manufacturing of computer displays is not that much difference, so we got this strong force towards having computer screens also in 16:9. Now, the interesting, of course, that's something that you mentioned before as well, is there are, again, some standard sizes, and here they are. So these are the names of it, and I have no idea how they ever came up with those names. But this is it. The proportion, the aspect ratio, and then the width and the height, and so forth. You might need that. Practically, again, here on the right is a little tool from Google called brother size. And the idea is that you can actually type in a web size. If you design a website, they keep statistics on how many people have what kind of screen. So you can actually see how many people will be able to see your website. So you see now 95, so orange is 95, so 95% of the people will be able to see that of your web page, and say around 50% of the people will be able to see everything. So this is a good way of testing your web design to see how many people will actually be able to see what. Because maybe we're a bit spoiled, maybe our machines are too good, and then you assume too much. In terms of screen size, there's also a nice little tool where you can just type in your the resolution. It will get automatically. You just have to say how much diagonal size your screen is, and it will pop out the DPI of your screen. Interesting, DPI, dots again. Should be PPI, shouldn't it? But when we talk about weights, this is essentially the weights that are typically being used. So usually your office paper is below 150 grams per square meter. Very often it's 90. That's sort of like the typical one. But then there's, paper is defined as up to 150. Then you get, semi-cardboard, cardboard, and so forth. This It's pretty much, you can put higher weight paper through inkjet printers, but putting them to laser printers is usually not a good idea. It's very unforgiving. So don't try that. File formats. So, what does PDF stand for? We know it, right? Portable document format. PDF, what's the relationship between PDF and PostScript? You know PostScript? Ever heard this? Okay. Which one came first, PDF or PostScript? Uh-huh. And what is PostScript?
The original script.
Script, meaning?
Not script, like writing format.
Mm.
Not too sure. No, it's vector. That can't be right.
So it's a vector text.
Yes. It is a page description language. So a PostScript file is nothing else than a text file that will say, at this coordinates, make a rectangle of that size. So back in the days, people were actually writing PostScript files by hand. You can do that. These days it got a bit complicated, but anyway. So who came up with PostScript? Not this time. You only have two choices with these things. You know, it's either the Germans or the Americans. So, who came up with PostScript?
Whoever invented the computer.
Yeah. No, that's a bit too early. So why do we have PostScript anyway?
Legacy reasons.
There was a reason why it was invented, and it was invented, like most inventions are invented, to overcome a certain problem, right? So what was the problem at the time that PostScript was invented?
The maintaining like resolution of object when trying to print it.
Yeah, in a way. Okay, maybe you're too young for that. The problem was that back in those days, if you wanted to print something, the printer would, for example, store the fonts, right? And your printer could do like 10 fonts, great. But then the problem was, well, if I have a document and I want to print on different printers, then I've got a problem because maybe the fonts are not the same. So what you want is to have a way of describing what it is that you want to print independent of the actual printer. It's an abstraction layer, right? No matter, as long, and then the only thing the printer has to do is to understand PostScript. And that's why all it says on the printer, supports PostScript. It means it understands this description language of what is should be printed where. Well, see, that's all very nice and good. And who came up with this again? The Americans, but who exactly? Adobe. And who came up with PDF?
Adobe.
So, what is Adobe? Well, what is PDF?
Like the same thing, but with images as well.
Yes, well, roughly. PostScript can also include images in terms of bitmaps. That's not the same. But again, they had PostScript, everything working, and now they come up with PDF. What was the problem they were trying to solve with PDF that they could not resolve with PostScript?
Supporting layers for representing multiple things.
No, that you can do in PostScript as well.
Okay.
So when did PDF roughly came around?
In the 90s.
Mm-hmm. And what happened there with computers in the 90s?
They grew rapidly.
Well, they always did that. No, there was one major thing that happened in the 90s. The internet. So, what problem did Adobe try to resolve with PDF?
File sharing, documentation online,
Yeah.
or just in general.
Well, you mentioned already a couple of things there. So essentially what you needed is that suddenly you didn't have just the relationship from my computer to my printer, but it was from my computer to another computer, right? And then internet could do all these multimedia things, like forms, movies, all this great stuff it can do. And Adobe wanted to keep up with that. So they came up with PDF. So for example, you can embed movies into PDF, no problem. A lot of interactivity you can put in there. But ultimately, actually, it is still PostScript. So the relationship is very simple. PostScript is done in a certain way. It always says 1.2, 1.4, 1.6, and so forth. So PostScript 1.4 equals PDF versions 5. 1 plus 4 equals 5. That is the relationship. It's just the standard. So essentially, it is still the same. Now, but PDF can do much more that PostScript cannot do, which is mainly about interactivity and multimedia. Now, which brings us to another question. So if you have a Word document and you write it and use some very elaborate typography in it, and you send it to you, and you open it, will you see it the same way as you designed it?
If he's got the same icon, not icons, the leader sets as database, hopefully we'll see it.
So maybe he do, maybe he doesn't. So that's a problem, isn't it? So what you want actually is a document that looks the same, no matter what your computer. Right? Does that ring a bell?
Yeah.
So same problem. Document printing on multiple printers, document shown on different screens and computers should always look exactly the same. Right? And again, one of the biggest problems, as you mentioned already, is you called it icons, but it's actually about fonts.
Fonts, yeah, sorry.
Yeah. So if you don't have the fonts installed he used, you cannot see it. But with PDF you can. Why?
Because it's stored as a vector. Well, it could be stored as a vector object.
You could transform it to a vector object, but then of course you would lose the possibility to easily edit it. No. So what do you do?
Write it as PostScript.
Yes, but for this to work, what do you need to do? If you have used a certain font that he does not have.
He needs the knowledge of the font that I'm using.
Exactly. So what do?
Send him the font name.
Exactly. So what PDF does, it embeds the fonts inside of the document. By default, yes. And that's how you can maintain consistency.
That would be a great practical joke, is to send someone a PDF without the fonts and something that's urgent.
Yeah, it will. That can sometimes cause problems. Yeah. So that's the fun story of PDF and PostScript. Now, when we talk about bitmap, it's slightly different. And there's a major difference between compressed and uncompressed. So why do we compress things?
Here's their size.
Yeah, that's of course true. So that's why we have JPEG. When did JPEG become popular?
Late 90s.
And why is that?
The internet.
The internet. So it's faster to transmit a JPEG than a file format that is not compressed. But there's something happening. There's the disadvantage of compression, which is?
Quality of image.
Distortion.
Not distortion, yeah, well, in a way. So how does compression actually work?
Well, so as you heard,
That's another story.
Yes, of course. Roughly speaking, in rough terms, not the exact algorithm, but
So you throw away information
exactly.
that you consider to be the least significant.
Yes.
that would be for lossy though. So
Yes.
for lossless, you're going to find similarities in data. So you're going to find sections which are identical to other sections, which then you can represent with one small bit of information.
That is then essentially something that GIF does.
Yeah.
Yeah.
Well, you had like a large amount of white space. You could set something like, this is the start of the white space, this is the end of the white space, so I don't need to continuously factor in all of the in between.
Yes.
Exactly.
And reduce that amount of data.
That is lossless.
Yeah.
And it's good because you don't lose quality. But JPEG is not lossless. JPEG is lossy, meaning you leave out information, right? You have to, otherwise it doesn't get any smaller, right? Okay, now let's imagine you have Photoshop, right? And you open your JPEG, you do something, and you save it as JPEG. And then you open it, do something, and you save it again as JPEG. If you do that 10 times, what happens?
Quality degrades further and further.
Yes. You thoroughly lose quality and will look after, in the end, very, very ugly. You have so many artifacts in there. Right? Now, what does that mean for your work?
Work in lossless formats, and then
Yes.
finally at the production stage, you move down to lossy.
Exactly. So don't use JPEG. Don't use any kind of lossy compression format for your file formats unless you're at the very end. Right? Now. Right. And there's another myth around it. Of course, saving a JPEG saves you disk space, right? Because on the disk it will take less memory. But will it also require less memory in Photoshop?
Memory.
In terms of RAM?
No, because it has to work.
Yes. So if you think that, oh, I don't have so much memory in my computer, so I'd rather save it in JPEG because it's smaller and my computer doesn't have so much RAM, think again. It doesn't work that way. So it doesn't reduce the amount of RAM you need to represent the data in your working memory. So the only reason then, again, the only reason to use a lossy compressed format is at the very end, and only if you actually go to the web. Because if you go to print, who cares? Right? So only when, for the web, essentially, you need lossy format.
Just on PNG,
Mhm.
is that true if you resave PNG over and over, the same problem will occur?
I think so.
Okay.
PNG is one thing that I actually have to look up a little bit more.
Yeah, I just didn't think it did lose information in the same way upon multiple resaves.
I have to double check that one.
Okay.
But essentially, when you work, the normal practice is just use PSD. Just use the Photoshop native format, with all your stuff. And when you're done, and if you want to produce, then you can move over to compression, but not before. Or if you want to be a little bit less bound to Adobe, you can, for example, use TIFF. TIFF is a pretty reliable file format. Pretty good.
Compresses very well.
Yeah. It has some compression and lossless compression algorithm. Which brings us to our next question. So, software. What software would you use if you were to edit a photograph? With a spray can. Seriously.
Photoshop.
Photoshop. If you don't want to spend the buck, is there a free alternative? GIMP. If you were to make a flyer, no, this is not a flyer. If you were to make this, what would you use?
Combination of software packages.
Yeah. If you are to make this, what would you use?
Say the same thing I just said before. A combination of Photoshop and probably Illustrator and Word.
Well, yeah, of course, the copy editing might be done in a different program, but if you would do the final layout.
I'd probably do it in Photoshop.
This in Photoshop?
Yeah.
So you would do that in Photoshop?
Well, I wouldn't do all the lettering. I'd have all that pre-written, and then I'd cut that and then paste it as individual elements.
In Photoshop?
I've done it before.
Oh my goodness.
I'd like a new method.
Yeah. So why exactly is that a bad idea?
Well, it limits me to the amount of pages I can produce for a document. Like, I'm pretty much limited to one.
So every page, one Photoshop file.
Yeah,
Oh my goodness.
it's great fun.
Mm-hmm. And your typeface, is that then Vector or is it Bitmap or what is it?
It starts out in Vector and then gets rasterized.
Okay. In any case, it's a really, really bad idea.
Yeah.
So you were right. If it's a single page, you would use Illustrator. If it's more than one page, you use, what's another Adobe product that would fall into this category?
PDF.
Hmm?
Not PDF creator, PDF writer.
Mm.
I don't know.
I only know the two, Photoshop.
Okay, there are more. Books, booklets, anything and more with one page is InDesign.
InDesign.
Hmm? There's an alternative, Quark Express, and you can even do LaTeX. If you want to do a web page, what would you use from Adobe? Okay, the reason why I'm putting forward so much Adobe is that it's sad but true, but it has become the monopoly. There used to be another company called
Macromedia.
that used to do many other programs. And what happened?
They bought them.
They got bought by Adobe. So we're running short on choices, really. So it unfortunately, it has become pretty much the monopoly on software in this area. I'm not sure if that's a good thing, but that's the way it is. And if you want to go later on and work in a company, that's what they expect you to do. So Adobe. So if you were to make a website and you want to do HTML coding, what would you use? Dreamweaver. If you want to use some highly animated, interactive stuff, Flash. Yeah, there you go. So those are those. Now, we're almost at the end, and I have a little task for you. I'm certain you're going to enjoy. So, reproduce a picture of yourself. It's a color picture you should take. Ideally, I really like it if you take baby pictures. If you take a baby photograph of yourself, then ideally it should be like natural. So it would not be like one of those photographs where it's black in the dark in the background and they just flashed your face. You know, ideally you have a reasonable, nice background. You would have a fair proportion of your skin on it. So you're not like somewhere like this in the background, but you know, you're there. And I want you to start with a photograph. So dig out really an old photograph. Scan it. And then print it. Print it on 3 different devices. And your task is to make all of those 3 prints look exactly like the original photograph. Okay? And what you do is that then you take an A4 cardboard and you glue the original photo and the 3 copies onto it. Write your name in the back. Right? And that's something that you will bring with you next week, Monday, to the lecture. At the same time, I want you to take this, put it again on a scanner, scan it, and upload it to Learn, so I know who did what. Right? Questions? It will be part of the final grade, yes.
So when you say printing, how do you mean? This is like different printers, like that one?
Whatever you choose, I don't care what device you choose. The boundary conditions are, you start with an original photograph, you scan it, and then you reproduce it, print it on 3 different devices. You are free of choice what devices those are.
Do we need to describe what devices?
It's helpful. Cool. It makes it easier to talk about it.
What about the printing surface?
Can do that.
Sorry, I mean like the surface we're printing onto. So there's quite a few things we need
You
to.
can use whatever medium, any kind of paper you prefer to choose.
Do they have to be all the same?
The goal is that all three of them should look exactly like the original.
So demonstrating prowess, with the extra credibility for using a diverse range of printing.
I'm not sure if you get credit for it, but
I was going to say credit, but then I said credibility.
credibility. No. Again, it's free of choice. It just has to be 3 different ones, right? The choice is yours, whichever way you want it.
And so I could imagine trying to get them to look exactly the same would be quite a difficult task in the sense that you might run through many, many different photos before you get to that end. How identical do we want to go? Like, are we just
Perfection.
as best we can, yeah.
Perfection is rarely achieved.
Okay.
But the goal is,
Yeah.
the better it is, the more they look exactly the same.
Mm-hmm.
Okay? Task is clear?
Is it marked or is it pass fail?
Marked.
Marking criteria?
My liking.
Press the text.
Me like. Me not like.
Straightforward.
Yeah?
Doable.
Questions?
Is our next lecture on February the 27th?
Yes. It's next week's Monday at 3 o'clock, actually.
No, but there was one tomorrow with.
Oh, there are more lectures. Andreas,
Oh,
design will be on,
so the next design lecture is on Monday.
yes, at 3 o'clock, I believe. It says 4 o'clock, but I think it's 3 o'clock. So we switch to the afternoon, essentially. And again, if I were you, I wouldn't do any printing on Monday.
I think it's a bit late for it if you're leaving it to the end.
Yes.
We should have done maybe 100 prints by then.
Well, it's up to you. 2 more things. One is that in this schedule, you'll find that there is an open door on, I think, Thursday afternoon. And that means that's the time where you can come in my office and ask any questions you might have. It's in the schedule, it's in Learn, so you can just look it up there. Okay?